you recognize the system that you put in step 2 works. Your test users are satisfied that the responses they are getting, they are good and relevant. Then it's the time to start using production grade components in your RAG system. Here is what we gonna do in step 3. We'll continue to use Amazon Bedrock document processing and RAG capabilities. Use Amazon OpenSearch Vector Store for scalable similarity search capabilities that grow with your data. Use an automated pipelines for continuous document processing, ingestions, and retrieval. Use AWS CloudWatch for monitoring. Here is our architectures for step 3 looks like. The components that we are replacing is LensDB S3 with the Amazon OpenSearch services. There are 2 different OpenSearch services available. One is a dedicated mode and the other is serverless. These demonstrations will be spinning off a dedicated instance because we do not want a full-fledged solutions which is deployed in multi-AZ, but this is to demonstrate that you can scale that solutions to a highly available clusters. So however, when we will be doing a cost analysis, we will be using the OpenSearch Serverless to demonstrate if you want to deploy a highly available components for vector stores, what is the cost looks like. So there are 2 parts of these architectures. The first part is the ingestions, where you load the documents in your S3 that triggers the Lambda functions, and then Lambda functions utilizes the Bedrock services for embeddings and pushes those vectors into the OpenSearch services. The second portion of the RAG systems is a retrieval. In the retrieval systems, we have used the Streamlit applications that can be accessed by the users to inquire, to ask the questions to your documents. And that Streamlit applications will be running from a local systems. However, you can deploy on any highly available components using a load balancer. The current architectures that we have is a simple architectures. However, the focus here is uses of the right components for your vector stores. Okay, you can continue and scale these architectures for well-architected frameworks, which we are not demonstrating now. The focus here is how we can use the right tools that can help us get the best result, and that scales with your data. And here we have utilized only the OpenSearch services. Currently, Amazon supports 5 different data sources for your vector store. Number 1 is Amazon OpenSearch. Number 2 is Amazon Auto-Write Cells. You can use the Postgres to store your vectors. The second one is a third-party service from MongoDB Atlas. The fourth one is a Pinecone. You can also use your Pinecone accounts to integrate with your AWS. And lastly is the Redis Enterprise Cloud that also supports a vector store. For the step 3, the source code is available on the GitHub at this particular repo locations. The first one you are seeing is the dedicated instance for OpenSearch, which uses the lowest minimal configuration, currently M5.1, not deployed in multi-AZ, and it can be deployed using either Terraforms or it can be deployed using a CloudFormation templates. But in your scenarios, if you're really going to the productions, you can use the OpenSearch Serverless, which is fully automated, that scales with your workloads. So that's available in this second repo that we have. You can clone the repos, and as you can see, I have already cloned the repo, those 3 folders, the ingestion pipeline, retrieval, and the Terraform. Let's focus on the CloudFormation template that we have. What we are doing here, we are spinning off the OpenSearch service domain, and we are also creating a secrets in the secrets manager that will be utilized with the OpenSearch, providing the permissions that you can do, and to deploy this template you can. So once you download the systems, you need to have the prerequisites installed on your local computers or wherever you are executing these instructions. Once in your downloaded source code, you go to the command lines and run the AWS CloudFormations, use the deploy command for these CloudFormations. and it takes a good amount of time to actually spin up the whole service on OpenSearch. In my case, I have already run the solutions for you. So at the end of the whole process, once you have your infrastructures deployed, which is available in template.yaml. So once you deploy your solutions, you can go to the CloudFormation services. In the services, you're going to find your stack. We gave our stack name OS RAG just to show where it looks like. Here you can see it. That's our stack name. The stack gets deployed. You go to the event sections and you can look for any failure events. If there is some issues, you need to go back and fix it. You can, if you get stuck, you can always ping me or message me. All right, so the whole solutions gets deployed. We have deployed an OpenSearch domains. Let's search for the OpenSearch services. You go on the OpenSearch services. You need to go to the hamburger menu and go to your managed clusters because we deployed a dedicated instance. You're gonna go to the domains, and here is gonna list your domain that has been deployed. So when we are once your infrastructure is deployed, you're gonna see your OpenSearch cluster is running, is active, and you can see the version. Currently we just deployed in a single AZ, but in your production grade solutions we would recommend that you use multi-AZ for your OpenSearch services. Okay, so that's a good thing. Now let's go and let's go to the source code. So here we are in the source code. You go to the ingestion pipeline. So let me bring the architectures one more time. So what we have done so far, we have deployed an Amazon OpenSearch services and this secret AWS secret manager. We haven't deployed the other components that are part of this architecture. So now we are going to the ingestion portion of it, the lab portion of it, and that you're gonna find here in ingestion, this ingest pipeline folder, where it has a SAM templates to deploy the functions that we have created, the Lambda functions. This is the one I'm referring, this Lambda functions that we have created, that is available here in this app.py. And this is an infrastructure for it, and as you can see, we are triggering the Lambda based on the resource that we are creating, this S3 bucket that we are creating. Whenever a file gets dropped ending with JSONs, this Lambda gets triggered, and the Lambda is gonna process your file. So just to walk you through, it reads your file, stores locally, gets the secrets, and then it starts processing your OpenSearch. It will make sure that you have an index. If it doesn't have an index, it's going to create an index, and then it will read through each record that was received from your documents that was uploaded in S3, and each of these records gets embedded using the Amazon Bedrock, and it gets uploaded into the OpenSearch. So that's the second portion of the infrastructures we are referring, and you can go here once you are in ingest pipeline, after you have installed required dependencies, required Python dependencies. So we would recommend that you create your virtual environments and install all the dependencies for these projects. And once you have that environments active, you can do a SAM build and make sure that this SAM build succeeds. Once the SAM build succeeds, you can deploy the stacks for your Lambda functions. And here is some information that you can see. And here are the resources that are being created as a part of this CloudFormation stack that gets deployed from a SAM templates. Okay, once everything is deployed, it's going to print out your Lambda function name, and it will output the S3 bucket that was created. So now let's go back to your AWS console, go to the Lambda. Now go to the Lambda service, search for RAG, and as you can see, you can click on this, and once you are here, you can go to the configurations. You can get all the details about the permissions that you can see there, but the things we are interested is a monitor. So you can go here in the monitor and you can see whenever your Lambda gets triggered, you're gonna see here in monitoring section. So once you are in monitoring, click on the view CloudWatch. When you first time go here, there won't be any record, so it says that the log group does not exist because our Lambda function has not been executed. So keep that in mind. Once our Lambda gets executed, it's going to start pumping those traces into this particular log group. All right, now that's the things that we saw, the Lambda functions. Now let's go to the S3 bucket. This is where we're going to store our type S3. Go to the S3 bucket, click on the chart and look for the OS RAG solution. This is the new S3 bucket that we created. We can go here, go into the OS RAG. So when you come into this folder, there is nothing there because we haven't uploaded anything. So what I want you to do, use our data JSON file, the sample data that we have created, and let's drop that particular file here. So we're gonna store the file just to show you that our Lambda hasn't run. Now we are just waiting. We are trying to upload this and we expect the Lambda to run now. So we have uploaded, go here. We are hopeful the Lambda gets executed. Let's just refresh here. All right, as you can see that our log group has been created, and within the log group we can see a log stream for the first run that we had. It's showing its log traces. So as you can see, our Lambda function is starting. It's checking for the index. If the index doesn't exist, it creates the index. Okay. And as you can see, our Lambda function is individually processing all the records one by one. We have 100 records, and this is what it's showing, that we process all of them. And once the records are processed, embedded using the Amazon Bedrock, they get pushed into the OpenSearch. So once you are here in OpenSearch services, you're gonna see your OpenSearch clusters, and in OpenSearch cluster you can see how many documents has been uploaded, how much space is free. Just to summarize what just happened, we actually deployed the OpenSearch services. We also deployed this portion of the infrastructures, and we dropped a file and created embeddings, and we store those embeddings in the OpenSearch services. So the left portion of the RAG system is completed. Now let's talk about the right portion of the RAG systems. Now let's talk about the second portion of the RAG system, which is retrieval. That's currently deployed using a Streamlit applications. You can go here, you can see the details, how we have created a Streamlit application. It's very simple Streamlit applications. I can demonstrate to you, and you can run locally after installing the required dependencies. So just to show you, there is a requirements.txt file. Make sure that you have a virtual environments. That's what we recommend, and you have installed all these dependencies that's available in requirements.txt. So go into the retrieve Streamlit folder in your source code, go to the src. This is where our application is residing, and you can run a Streamlit run app. And as you can see, our application is running. Now this application is actually communicating. So right now I'm running as a part of my local systems, but you can run this as a part of the EC2 or containers or however you want to run. We are not showing the full-fledged systems, but our focus is only to demonstrate that you can build the applications using Streamlit and you can communicate with it. So once you are, and remember, Streamlit is, you can use a Streamlit, you can use React on a front end to create a very good applications. However, we are just demonstrating here with the Streamlit. So once you have Streamlit applications running, you can make an inquiry based on the documents that you have, the records that you have. So let me show you what kind of records that we have so far. So let's talk about bathroom leaks. Okay, we have the record. So I'm gonna go, is bathroom leaks covered? Let's see what it responds with. It's processing, as you can see, it's running. Okay, it come up with the answer. Homeowners insurance typically covers bathroom leaks, and this is what we just saw, a homeowners insurance, and you can read through it here and you will get all the details. So right now it's getting the first record and it's showing here on the screen. So yeah, this is how you can create a RAG systems with a production grade components on Amazon OpenSearch. Some considerations while implementing the RAG systems. These are coming from the well-known best cloud practices that you implement encryptions both at rest and in transit, and use the proper access control using AWS IAM and KMS. Ensure your pipeline adheres to the industry regulations like HIPAA, GDPR. What's the value propositions of the step 3? It's enterprise ready, that you can use robust, secure, and scalable for your business critical applications. Cost efficiency. Pay only for what you use for your OpenSearch serverless architecture. This solution adapts easily to your growing data and changing requirements.